Okay, with this lesson, we're still finding the function of the gradient or the derivative, but this time we're going to see, and it's still using the same rule, but we're going to see negative powers, and so we're going to see what we do. Like, you still do the same, but just to give you some examples. So if we've got here, find the derivative. So the function that they gave me was x power 4 minus 2x power of negative 3 plus x negative 1 plus 2. So we know when we find the derivative, which I can demonstrate with f dash of x. So we go 4 times the number in front of x, which is 1, so it'd be 4x, and we reduce the power by 1, so we minus 1, so that becomes 3. So now we have, in the next one, we've got negative 3 times negative 2, which becomes plus 6. And if we reduce the power by 1, we actually go minus 4. Okay, and now with the next term, we've got negative 1 times 1, so we've got minus 1, and we would be reducing that power by 1, so it becomes negative 2. So there's the derivative, and remember we could write it dy dx too if we wanted to, and it'd be 4x 3 plus 6x negative 4 minus x to the negative 2. Okay, so nothing different. You just got to remember when you've got that negative power, you're minusing 1, so it goes smaller. Okay, so find the derivative of this when they're just saying the function can be any, mapped onto any, the domain can be any number, but not 0. All right, so we've got the function here. We're going to find f dash of x. And we're going to, off we go. So it'd be 2 times 3, which is 6x, and I reduce the power by 1. Then I've got negative 2 times negative 6, so a negative by a negative becomes a positive, and I've got to reduce that power by 1, so it becomes negative 3, and then we lose the thing. So there's the derivative of that function. If we go on to this next example, now, it's asking me to find the derivative of this function or find the gradient. So the gradient, we need to get the rule for the gradient, and that is, the rule for the gradient is f dash of x. So and we need to find the gradient at that point. So they're giving me an x value and a y value where they want me to find it. So if I wrote out this is the formula, x squared plus 1 over x. But we know that that could also be written as x squared. Remember, 1 over x could be written as x to the negative 1. So if we go to find the gradient or formula, so dy dx or the derivative, we'd have 2x, then it'll be minus x to the negative 2. Okay, now they want me to find the gradient at the point. So at the point when x equals 1, the gradient dy dx equals, and it'll be 2 times 1 minus 1 to the negative 2. Okay, or now remember that could also be written as 2x minus 1 over x squared, if that makes it easier. So you could say it ends up being 2 minus 1 over 1 squared, which is 1, so we get 2 minus 1, which equals 1. So the gradient at this point is 1.